In this video, we're going to learn about Eulerian path and circuit and Hamiltonian path and circuit. Now, whenever we have Eulerian concept, we just try to visit each and every edge of the graph exactly once, and whenever we have Hamiltonian concept, we just try to visit each and every vertex of the graph exactly once. Leonhard Euler. He is also called as a father of the graph theory because he had invented something was very basis for the graph theory. He developed the problem for the Königsberg bridge problem. The problem is that you are having Königsberg bridge, and here this is having kind of we are having two islands. They were connected by the seven bridges, and we just have to start from one point, and we just have to travel each and every of this bridge exactly once and come and again come back to one particular point. So this was not possible. Based on this, Euler developed the concept of Eulerian path and circuit and graph. So what is Eulerian path? Eulerian path in a graph is a path which visit every edge exactly once in a graph. And Eulerian circuit in an Eulerian is an Eulerian path which visit every edge exactly once, but the exception is that we are starting with some particular vertex and we are again ending at particular vertex. For examples, I can say that here, if there exists a kind of path where we can meet each and every edge of your graph exactly once, then that could be called as your Eulerian path. Now suppose I want to start from this vertex A, and I'm just traveling with this edges. Now this is visited, this is visited, and this is visited. Now each and every edge of your graph is visited. Now this kind of path will be called as Eulerian path. Now as I have started with one particular point and I have just ended at that particular point, so this will be called as my Eulerian circuit. Now this will be my Eulerian circuit. Now the another for example, at this particular place I'm starting at this vertex v2. Now again I'm going with all of this particular vertices, and I have visited all of these edges, and what happens if I will come back over here, this vertex v2 is I'm just submitting to that particular vertex, and again I'm coming back to this particular vertex. Now here each and every edge is visited exactly once, but meanwhile we have visited this vertex v2 twice. No concern, but there is we are not bothered about how many times we are visiting that vertex. Just we want to give focus on visiting each and every edge exactly once. And if there exists Eulerian circuit in your graph, then that graph is called as a Eulerian graph. Now, theorem for Eulerian concept for the undirected graph is: an undirected graph has Eulerian path if zero or two vertices have odd degree and all other vertices have even degree. Now here we are having either we should have count of two vertex whose degree is odd, or no vertex which is having degree as odd. So means if your all of the vertex in the graph are having even degree, then your that graph will, of course, it will have Eulerian path. So this graph is having this each and for every vertex we are having degree as 2. So this exists Eulerian. In this graph we have the Eulerian path. Now second theorem is that an undirected graph has Eulerian circuit if and only if it is connected and its all vertices have even degree. Now in this particular graph we can say here, this in this particular graph we have Eulerian path, but we don't have the Eulerian circuit. Why? Because the degree of each and every vertex is not even, so this is having odd degree. So if we will start at any particular vertex in this graph, by any chance, suppose I am starting with this, I can travel all of this particular vertex. Again, I'm not going back to this particular vertex. Anyhow, I just end up with another vertex. So I am not able to form a circuit. So this graph is not having that Eulerian circuit because degree of each and every vertex is not equal. So that's why we can say this graph doesn't form your Eulerian circuit. Theorem 3 is, if you are having directed graph, then in such a graph, how to find Eulerian path? So a directed graph has Eulerian path if and only if it is connected and incoming degree is equal to outgoing degree for every vertex. Now, for example, this vertex is having incoming degree as 1 and outgoing degree as 1. Now this is the same case for each and every vertex. Now this vertex is having degree incoming degree as 2 and outgoing degree as this vertex is having incoming degree as 2 and outgoing degree as 2. So incoming and outgoing degree is exactly equal, with possible exception of two vertex, where we are having just incoming degree of one vertex is equal to outgoing degree plus 1 of other vertex, and this is the case. So if there exists two vertex, except that vertex, for each and every vertex we are having the equal incoming degree and outgoing degree, then that graph will, of course, that directed graph will have a Eulerian path. And the last theorem is a directed graph has Eulerian circuit if and only if it is connected and incoming degree is equal to outgoing degree of each and every vertex. Then we can say that that graph holds a Eulerian circuit. And of course, if the graph has a Eulerian circuit, we say that that is Eulerian graph. Next is we are having a Hamiltonian concept. Here, Sir William Hamilton developed the concept of this Hamiltonian path and circuit based on this visiting each and every vertex exactly one. So he were inventing some kind of solution for the all around the world problem. In that, such kind of graph was there, and he just having the problem that we should have to visit each and every vertex, not each. We want to visit each and every vertex in such a way that you should not meet that particular vertex more than once. So in your path you should visit each and every vertex of the graph exactly once, if that is not the circuit. So this is what we have to do. So for this particular problem, they found the answer by using this meeting each and every vertex of the graph exactly once. If we want to form a circuit, starting vertex and ending vertex will be the same. So based on this, we are having the Hamiltonian path. Hamiltonian path is a path in a graph that visit every vertex exactly once. So this is called as a Hamiltonian path. Now Hamiltonian cycle is a Hamiltonian path which visit every vertex exactly once, which starts and ends on the same vertex. Now for example, in this particular graph we just need to cover each and every vertex. So if I'm starting from this vertex v1, I will traverse all of these vertexes. So I will visit v6, v5, v4, v3 and v2 and v1. Now I will come back over here. So this is forming a Hamiltonian cycle. We are visiting each and every vertex exactly once. And if a graph has Hamiltonian circuit, so that graph is called as a Hamiltonian graph. So unlike Eulerian path and circuit, there are no necessary and sufficient condition to determine Hamiltonian circuit or path. It's just a sufficient condition. So there exists some kind of theorems on this Hamiltonian concept. So theorems first is, let G be a simple connected graph on n vertices if sum of degree of each pair of vertices in graph is n minus 1 or large, then there exists a Hamiltonian path. Now for example here, this sum of degree of each and every vertex, so pair of vertex, suppose we will take these two pairs. Now sum of the degree is 4 plus 2, that is 6. Okay, now then if sum of degree of each pair of vertices in the graph is n minus 1 or large. Now here n is 1 2 3 4 1 2 3 4 5, 5 vertices are there, that is 4 or large, then we could say Hamiltonian path exists. Okay, and suppose if you will take this two particular points, so the degree of this is 2 and 2, so it will be 2 plus 2, it will be 4. So it should be greater than equal to that of your n minus 1, that is 3. So we can say that this exists. But what if we are taking the example of this particular vertex, where suppose we are having 6 vertices and suppose degree of this 2. So if we perform addition of this 2 degree, that is 4. So it should be greater than equal to your n minus 1. So that is n minus 1. Total number of vertex is 6 and 6 minus 1 is 5. That is not greater than equal to 5. But still it forms a kind of Hamiltonian path. In this we have Hamiltonian path. So we can visit each and every vertex of this graph exactly once. So this condition is just sufficient, but it is not necessary that we should have for each and every of this graph. There is also another theorem. if we are having a graph which is a simple connected graph on n vertices, and if the degree of each vertex is greater than or equal to n divided by 2, then the graph will contain the Hamiltonian circuit. And for this theorem we can use this particular graph. Here degree of each vertices is greater than or equal to n by 2. So here total number of vertex are 6, and we should have degree of each and every vertex should be n by 2 or greater than or equal to your n by 2. So suppose for example here n by 2 is 3. If degree of each and every vertex is 3 or greater than 3, then we can say that this graph will surely have the Hamiltonian circuit. So this follows the theorem 2. Now theorem 3 is there is always a Hamiltonian path in a directed complete graph. Now if you are having complete directed graph, then your graph will always have a Hamiltonian path. So but for this theorem 2 doesn't follow, so we are just having these conditions that is not necessary that should follow for each and every type of this graph.